Okay, the same thing. I always know how to start a problem.
Just write them all down, baby.
Admit that I don't know anything.
Yeah. And now let's just start sorting it out. It's going 3130 meters per second. That looking like an initial velocity to me.
Indeed it is.
Yeah. And another way you can tell is one of the questions they ask you is find the final velocity.
It asks for the final. So if they gave you the final line, it'd be like,
So now we got an acceleration of 0.00135 meters per second squared. If we were doing that crazy scientific notation thing, it'd be 1.35 times 10 to the negative second. Get prepared for that. That happens sometimes. Third. Oh, duh. Third. Yeah. Well, anyway, thanks. Like I said before in the previous video, it's been a long day. It's okay to make mistakes sometimes, boys and girls. So the distance is 5.5 times 10 to the 9th meters, and there is the aforementioned scientific
that is, by the way,
notation.
5.50 gigameters.
Gigameters. It's a lot.
That is.
So we're looking for time and final velocity. What do we do from here, man?
Let's see. So time, to solve for time, okay, there is a formula here that'll solve for time. It's the one that doesn't have v final in it. That would be this one, okay? Now, this is not going to be a loving equation to use.
Oh, no.
Okay? And that's because we know this guy is 5.5 times 10 to the 9th, right? Equals 3130 t plus 1/2 times 0.00135, right?
Yeah, 135.
T squared. If you recognize this, this is actually a quadratic equation. Now, that's just fine. You're going to solve it. You're going to get a positive root and a negative root. The positive root is the one that happens in the future, and the negative root doesn't mean a lot. Okay? So if you like the quadratic equation, just go ahead and do that. But let me show you a trick here. It asks for them in this order, but can't we solve for this guy first? And maybe that guy will help us solve for time, right? So I'm going to choose to do this guy first and this guy second.
Yeah, and that's the kind of take-home message here. Just because one of the questions asks for one thing, if you can apply the easiest formula, just do that. You know, do that first. Why not? It's easier.
So if we go back to the idea here, right, we want to solve for the final velocity. We want to use one that doesn't have t. Well, that one's got t, that's got t, this one doesn't. So let's use that guy. Okay, so let's see, what do we got? Final squared, we don't know what it is.
We don't know what it is. Yeah, 3130 squared. I'll get to work on that.
Plus 2 times 0.00135 times 5.5 times 10 to the 9th.
Okay. So the first thing is 3130 squared is a big number. 9796900. Okay, so that's that part.
9796900?
That's correct.
Okay.
At least I'll double check that here, because that would be sad if we were doing the problem and we didn't do it right. Yeah, that looks good to me. So then we get 2 times 0.00135 times 5.5 times 10 to the 9th. Oh, no, that's not going to work because it's the other calculator. Okay, there we go. We get 148,500,000. So 4 zeros. Okay, so that's a lot. I'm going to add it to my previous answer. And that becomes 246,469,00. And now we got to take a square root of that, right? And we'll show you some tricks in class for how to handle it with your TI, but the square root of that ends up being 4,964 meters per second. 0.56, there you go.
It's only that, right?
Yep.
Okay, so now we've got the final velocity. It could be positive or negative, but it turns out in this case, I'm just going to look at the positive velocity. There will be cases, though, where we've got to look at that with more scrutiny. Okay. Okay, so there we go. We got that, right? And then now we want to find the time, and the best way to find the time, I think, is to use this guy here. That's the simplest one. Okay, so I'm going to use V final equals V initial plus AT instead of this one, right? Okay, so the final velocity is 4964.6 is 3130 plus 0.00135 times t.
So isn't our first step to remove 3130
We're
from
going to
both
subtract
sides?
that from both sides.
So 4964.6 minus 3130. We're looking at 1834.6.
Is 0.00135
Yep. Times t.
times t. I'm going to write that again up here just for fun.
Sure. Then
Okay.
our last step
So
is to divide.
0.00135 times t, right? And then you're going to divide both sides by 0.00135, right?
Mm-hmm. And boy, oh boy, do we get a big number. We get
That's crazy.
1358962. Actually, 3. Just round it up because it's 0.96. So there you go. Now that is going to be in seconds, and we don't want to report it with all those things. So we could say that it's 1.36 times 10 to the 6th. And that's what that E in your calculator means. It's
I'm using
calculator
calculator
language
notation.
for times 10 to the.
Yeah.
Times 10 to the. And for those of you keeping track at home, that's a long time. That's 22,000 hours.
Minutes?
Minutes.
About
22,000
60 again.
minutes. Or about 377 hours.
So this is actually rockets that exert this tiny force and cause these tiny accelerations are usually ion propulsion systems. Google that. They're
Ion
cool.
propulsion systems.
And the code word.
That is ion propulsion systems.
The code word is ion propulsion system.
That's right.
I believe so. I know that's more than one word, but we're calling it the code word.
Code words.
It's like
code phrase.
Yeah, I mean it's like
Really.
Yeah, it's like the special car.
Mm-hmm.
Yep.